Hello everyone, I'm Noah Wahlberger. We've been talking about the sociology of mathematics and especially number systems throughout the ages. And we've been talking about the Babylonian system, the Egyptian system. These are both pretty advanced. And now it's time to talk a little bit about the Greek arithmetical system. So in most modern treatments of history of maths, the Greeks feature very prominently. And it's usually the idea is that modern mathematics in a very broad sense, sort of originated with the ancient Greeks. Now, while that is largely true, I think it's probably the case that the contribution of the Egyptians and the Mesopotamians has been underrepresented, and their influence on Greek culture especially has not been given enough credit. So it's really these ancient civilizations which I think are really at the heart of the development of the modern world. That's apart from the Chinese and the Indian civilizations further east. So what about the Greek numerical system? Well, although the mathematics of the ancient Greeks was very well developed and huge contributions in a lot of areas, surprisingly, their arithmetic was, let us say, somewhat primitive, especially when you compare it to the Babylonian system, which is 1500, almost 2000 years earlier. So when we talk about Greek mathematics, it's not just present-day Greece. It really is a culture that was spread out across the eastern Mediterranean, and ultimately into Africa as well. So from around 600 BCE to around 400 AD, so a 1,000-year period, and one can segment that up into various epochs in ancient Greek mathematics. And originally their arithmetic, sometimes called the Attic system, was surprisingly similar to the current-day Roman numeral system. So there were, it's basically a decimal system with special symbols for 1. 1 was just a vertical stroke, like it is in most places. And then 5, 10, 50, 100, 500, 1,000. And so you'll recognize that's very similar to the Roman system, with these numbers represented by symbols, which were letters, essentially. So that was the Attic system, but that was actually only one of a couple of different systems. Okay, so somewhat later, another arithmetical system called the Ionian system was developed. And here there was a closer connection between the numbers and the letters of the Greek alphabet. So in particular, each of the sort of simple numbers actually had a specific letter associated to it. So 1 was associated to alpha, 2 to beta, 3 to gamma, 4 to delta, etc. Okay, and then when we get to 10, then multiples of 10 also had individual letters associated to them, and similarly multiples of 100 also had separate letters associated to them. Now you'll see mostly familiar symbols here, but there's a few that maybe we don't have in the modern alphabet. So this 6 symbol, this 60 symbol, this 900 symbol, for example. But more or less we see pretty well the Greek alphabet here represented in this system. So for example, our number 35,298 would be represented by this combination here. The lambda is 30, and the little comma sort of in front of the lambda is telling you that you need to multiply by 1,000. So this is like 30,000. And this little comma in front of the epsilon is 5. That's telling you that you should think about that as 5,000. And then we have a sigma, which is sigma, that's 200, there we are, right, the 200, and then the 90 down this funny symbol, and then the eta is 8, okay? And sometimes they also use the sort of a capital N for 10,000. So this is the Ionian Greek system for arithmetic. Now with such a system, it's easy to get words and numbers confused. So eventually a bar system was adopted where you put bars over letters if they were to represent numbers. So this mu epsilon with a bar over it would be 45. In terms of fractions, well, they more or less followed the Egyptian example here and concentrated on fractions of the form 1 over a natural number. Okay, and they denoted that with an accent, okay? So theta, which is 9, there's a bar over it telling us that's a number, and this theta prime telling us that we should be thinking about 1 over 9. Okay? So it's interesting that the Egyptian approach to fractions appears here also, that we see this sort of naive idea that, you know, the simplest kinds of fractions are just the reciprocals of the natural numbers. When I say naive, I don't mean in a derogatory way. I just mean sort of like a sort of an obvious sort of way of proceeding. So while both of these Greek numerical systems were adequate for bookkeeping, in fact, they were quite efficient for bookkeeping because you could record numbers in a particularly simple way, especially with the Ionian system. There's no need for repeating things. You just have all these letters at your disposal. However, calculations with this system, as you can imagine, are quite onerous. If you try to do calculation in the Roman numeral system, you'll appreciate that you know, this multiplicity of symbols, which are in some sense rather arbitrary, doesn't really lend itself to sort of systematic calculation. So, and we can see evidence for that in the later Greek period. Ptolemy of Alexandria lived around 100 to 170 AD, the most prominent or at least famous astronomer of the Greek world. He adopted the Babylonian sexagesimal system for astronomical work. So even in his period, it was recognized that the arithmetical system of the Greeks was just not powerful enough, or at least not when compared with the Babylonian system, the sexagesimal system. This is pretty interesting, okay? And because of the huge popularity of his main work, the Almagest, which ended up being very influential later in Arabic work, and then in the medieval period into Europe in the Middle Ages, this appreciation for the importance of the sexagesimal system actually was quite widespread. And so it's really, again, remarkable that, you know, there's almost as much time separating Ptolemy and the old Babylonians as there is separating us and Ptolemy. Okay? So he was using a system that was much earlier than his and recognizing that it was essentially superior for computation. It's interesting, especially interesting to ask the sort of delicate question, well, could that still be the case now? I mean, if we were going to start again, would it make more sense to adopt a sexagesimal system? That is a pretty interesting question. So the weaknesses of the Greek system for computation was also appreciated by Archimedes, the greatest mind of antiquity, who lived earlier from 287 to 212 BC. And in one of his books called The Sand Reckoner, he takes up this challenge of trying to calculate how many grains of sand would fit into the known universe. This is a very interesting work because, first of all, it's pretty well the only example that we have of Archimedes delving into the astronomical zone. And secondly, because he adopts basically a heliocentric point of view. So his view of the universe is with the sun at the center, okay? So that's not just Copernicus. The ancient Greeks, at least some of them, were already of this mind. And it's also interesting because he appreciates that the ancient Greek numeral system is just not powerful enough to deal effectively with the huge numbers that ultimately he's going to require. So in our language, he ends up with an answer which is roughly 8 times 10 to the 63. He makes various calculations that, that depend on the distance from the Earth to the Sun and various assumptions about the known universe. Okay, so obviously he's not in possession of a lot of the really relevant facts. But anyway, maybe we aren't either, okay? But anyway, he was able to deal with these numbers, but he has to do so by essentially inventing a number system for bigger numbers. So roughly something like, an exponential kind of notation, but in this still Greek framework. So he introduces things called myriads, and then myriads of myriads, okay? And this allows him sort of to build a ladder to be able to access a number like this. So that's pretty interesting, and it shows again Archimedes' genius, but also the fact that the Greek system is really just not that strong in terms of numerical calculation. In fact, that's why these days that system has more or less disappeared. There's not much traces of it. People don't study it very much. It didn't have really that much long-lasting influence, even though the rest of Greek mathematics, especially their geometry and indeed their number theory, proved to be hugely influential in later centuries. There's another curious consequence of the Greek method of associating numbers with letters called gematria, which nowadays is sort of a quaint historical curiosity, but during the day it was actually taken quite seriously. And that's the idea that once we have this association between words or letters and numbers, then if you have a word, that word can be interpreted, in terms of numbers. For example, you could add up all the digits, or you just interpret it as a number. And so that means that words can be ultimately interpreted as numbers, and so a kind of a numerology appears. So in particular, I think a lot of kind of superstitious things sort of arose from this. For example, it was argued that Achilles beat Hector, back to the Trojan War, because the number associated to his name in Greek turned out to be 1,276, while the number associated to Hector was 1,225. And this number is bigger than this number, so that's the reason why Achilles was able to defeat Hector. Okay, so there were a lot of investigations in this direction, looking at religious texts and finding hidden numerological meanings behind various phrases, etc., etc. And these days, this is all just a curiosity, but it's interesting that this did really occupy a lot of highly intelligent minds for quite some time. And so, it's maybe another indication that it's not so hard to go astray. It's not so hard to be convinced by the mind frame of the times, and end up spending a lot of time in directions which ultimately to future generations are somewhat futile. I'm Nolan Wildberger. Thanks for listening.